morning. It's 8 o'clock, and right now, I don't know, I'm on, oh, do you need to see this, Nicole? Okay, there you go. Does that work? Okay. All right. Well, we got enough electronics here. Hopefully we're not going to have cause a blackout in Southern California here. All right. Am I in the center of the screen? Yes. Okay, good morning. It is 8 o'clock-ish, 1 minute after, and I think I'm finally ready to go. Anyhow, welcome to our continuing series on hazard and operability studies. Our objective is to have a number of modules that build together for those of you who want to tune in by webinar for our 3-day course that'll provide you with all the essentials for facilitating HAZOP, good quality HAZOP studies. This is being broadcast via webinar. Obviously, there's a lot of electronics involved. We do our best to minimize that, but if there are problems, you do have a number on the screen, 949-282-0123. You can call in, somebody will answer the phone, and somebody will endeavor to help you get any problems that you've got resolved. Also, because it is a webinar, we are broadcasting to a large number of people. We do have the ability to have interactive two-way communications. However, given the fact that you may be shuffling papers, having other meetings, phones ringing, etc., we've muted all the participants until the end with the question and answer session. Today, actually, let me review the previous agenda. A little bit more about logistics. We'll be going through our presentations. You were all given PDF files, copies to follow along. The main speakers today will be myself, Steve Maher, and also Judith Sakairos. And also supporting the webinar is our own Hurricane Nicole Tromba, who basically will be our producer today, and will be also monitoring a chat window if you have any questions or issues that you'd like for her to resolve. So anyhow, a little bit more about what we're talking today, and I guess a little bit more about us. Risk Management Professionals is an engineering consulting firm. We do specialize in these types of activities, and it's the sort of thing where we endeavor to share a lot of our knowledge and technology so that people can do good quality process safety management, risk management programs, and in the offshore world that translates to safety and environmental management programs, and that may be part of the upcoming safety and environmental management systems regulation. Overall in the series, the Module 1 involved regulatory requirements, overviewing it, and also providing a case study. Module 2 looked at HAZOP study mechanics, quality tips, consequence analysis. Today, I'll be speaking primarily on PHA preparation, and Judith will be focusing on good quality piping and instrumentation diagrams and other drawings that are essential for doing a good quality hazard and operability study. What you're looking at is one of the PDF files that were sent to you. In that package were an overall course agenda so you can see what's coming up and what our normal 3-day course looks like. It's also a little bit of background curriculum vitae for Judith Sakairos and myself, and copies of the presentation materials for today. So we'll be focusing on PHA preparation and P&IDs today. Upcoming topics will include scenarios, workshops, facilitation tips, more workshops to really have everything come together, how to integrate layer protection analysis, safety instrumented systems, safety integrity level issues, QRA, and pulling all that together for an overall HAZOP study that integrates with a lot of the other things that you may have to do for an overall safety management systems program. Also want to talk about revalidation. That's another real key issue. That'll be coming up in Module 9. Team facilitation, we're going to get something very interactive going for Module 10. Then Module 11 will look at a lot of key issues that classically hadn't been done very well. Human errors, human factor issues, facility siting. Also, how do you integrate hazard and operability studies to various stages of the design cycle for a plant. And also, Module 12 will close with a lot of specialty items. A lot of people use double jeopardy inappropriately. How do you integrate those concepts into HAZOP studies, looking at multiple consequence categories, etc. Okay, so that's the overview of what we're doing as far as the, we're going to shift over to 2A, Nicole. Oops. 3A, thanks. Okay. This is the PDF file in your package that starts with 3A. And what I'll be focusing on is preparing for PHA. Again, in previous modules, we looked at the history, the regulatory bases for process hazard analysis, what industry did in response to some major incidents that occurred, looking at PHA characteristics, available tools to help you do the PHA, overviewing contemporary techniques, and also how do you pick the right one for the project, looking at hazard and operability studies, the details, using the results, and also maximizing the future usefulness of the HAZOP study. And also various quality tips to make sure that the hazard and operability study not only meets the current objectives, but also future needs for your facility. The overall objective is to make sure that you've uncovered any potential vulnerabilities at your facility and can appropriately address them. Key topics that we're going to look at today is looking at the objectives and the scope of the project and how that factors into PHA preparation, looking at various tools again, also preparing properly for that, scheduling the team, picking the right team so that you can get a good quality process hazard analysis done, the venue. Venue, very important to make sure you can get the job done, and also making sure you line it up way in advance. Information needs, equipment needs, getting the technical information ready for the hazard and operability study, a little bit more on node selection tips, and also picking a good deviation matrix, summarizing the hazard and operability study approach, a good timeline for how to pull all that together and not getting caught at the last minute without having everything ready. And also at the very end, we're going to have a little quiz, a little mini workshop, and a group discussion this morning. So let's overview. I want to give you a big picture again so we don't lose sight of where we're going with the hazard and operability study. Again, you've designed a system, you use piping instrumentation diagrams or some other mechanism to design it to achieve a certain function. Like I said, P&IDs, which Judith will talk about more, emulate the function of the system. So what you want to do is translate that into looking at it another way and how it can break or how can you fail the system. Use a deviation matrix as we talked about before, apply various guide words, combining no with process parameters like flow to get deviations like no flow that can lead you down a path of challenging the system and uncovering potential vulnerabilities. The hazard and operability study, it has a rhythm to it. There's a very systematic approach to making sure that you ferret out potential hazards, segmenting things in the form of nodes, applying process deviations, looking at various causes that can go wrong, looking at the consequences of those causes, and developing a scenario so you can understand how likely the event is, how bad the event is, and gauge with the team, are the safeguards adequate or do you have a vulnerability that you need to address? It gets documented as part of a table typically where you list out the causes, consequences, safeguards, and any weaknesses that, or any recommendations to address potential weaknesses. So what you're trying to do is you're trying to use that design information, how the system works. You're using a tool like one of the process hazard analysis tools, like a HAZOP study, to challenge the system, to make it break on paper, of course, and identify what potential weaknesses there may be so you can fix that. So you're looking at causes that can lead to safety or environmental hazards. You're trying to recommend changes or things to address potential vulnerabilities or potential weaknesses. And then you're trying to provide documentation that provides background for those recommended actions. So that's the objective. You're trying to go from design information, use a PHA technique, challenge the system, and uncover weaknesses. So the whole theme for this is how do you do it successfully? Well, half of success is preparation, doing things up front so that you can effectively use your team and effectively uncover weaknesses. If you go into a PHA of any sort, especially a more complex one like a hazard and operability study, you're not prepared, you're going to be wasting a lot of time. You may not get the results that you want, and you may not have uncovered potential vulnerabilities that can wind up injuring somebody, causing major plant damage, or having a significant impact on the environment. So to achieve this preparation helps you get a high-quality PHA. It helps you effectively utilize the team, and also it can make sure that your session time is well used. A good preparation for a HAZOP study not only can improve quality, but it can also decrease the overall amount of session time that you may be encountering. So let's look at the key steps for preparation. First of all, it's defining the objectives and scope. If you don't know where you're going, how are you going to get there? A PHA can be done at a very high level early in the design stage, and I did one for a hydrocracker. We flew through it in just a couple of days, looking for high-level issues very early in the plant design stage so you could make major changes in a very cost-effective fashion. That was the objective. Later on, that same PHA will be used as a framework for a much more detailed evaluation, but very efficiently. So they got the job done early in the design stage, and additional details will be applied later. In the same way, different projects may have different objectives. Some projects may have a greater interest in safety issues, a greater interest in environmental issues. There are all sorts of reasons to apply these process hazard analysis techniques. Understanding what the objectives are from a safety, environmental, and operational need will help you prepare properly, get the information that you need, and get the right people on the team. Also defining the scope. Are you going to include vendor packages? A lot of times people get skid-mounted packages for lube oil systems, water conditioning, etc. Knowing if you're going to have to go into that will make you realize if you need to get certain types of information or certain critical team members. And of course, understanding the system boundaries. If you don't know where your starting point and end point are, you may not be getting the right information for that. Okay, step number 2 is getting the tools together. Well, knowing what you need to do is going to decide what kind of tool to pick. Just as if you're having a project at your house, knowing what you're going to do will help you assemble the supplies that you need at your local supply store and to gather the tools you need to get the job done. It's the same way for process hazard analysis. Understanding the objectives leads you to identify what tools you need, and if you need special software packages, you may need time to arrange for licenses, computers that can support that, and also making sure it was tested up front to make sure things function properly. Last module, we looked at the variety of tools that are out there to help with the process hazard analysis. On the left of your screen, there are simple things that we talked about, like checklists, what-if approaches. On the right side of your screen, in yellow, you'll see higher order tools like layer protection analysis, event tree analysis, and fault tree analysis. Knowing what you need to accomplish, what kind of decisions need to be made, will help you pick the right tool. The workhorse for process hazard analysis for complex chemical process systems is the HAZOP study. Most of what we're going to do is kind of focus on that and that HAZOP study team approach. And a facilitator may need to use all these tools depending on the project objectives. A HAZOP study is a good tool to uncover weaknesses on a qualitative level or semi-quantitative if you're risk ranking. For most chemical process systems, we're going to be doing a team effort looking for vulnerabilities using quantitative tools with a small group on an LPG storage system next Monday. When doing those sort of things, quantitative tools like fault tree analysis, event tree analysis, and LOPA may be very helpful. Okay, step number 3, after you define the objectives, you know what tools you're going to use so you can start arranging the tools, is the team. The team is where is going to make or break you. Getting the right people, having the right expertise there is absolutely critical. There are regulatory requirements with who has to be there, but even beyond that, don't just shoot for the minimum. Think about what's needed, what are the capabilities of the personnel. Each individual on the team is going to have a certain role and responsibility. We'll talk about that in a second. And it's important. These are some of the busiest people. The best qualified people are going to be the busiest people. So you're going to want to schedule them early, make sure they're calendared, and that can be a real challenge sometimes. And also, you got to let people be aware that they have to be there for the entire time. A team session for a PHA like a HAZOP study, you can't have people coming in and out. If people miss key parts of it, they'll just come in later and start asking the same questions, or you may be missing their critical insights at a time when you really need their support. So what does the team look like? From a regulatory requirements perspective, you have to have representatives from engineering, operations, and maintenance. You have to include a person who has knowledge specific to the process being evaluated. It doesn't help you too much If you're working on a hydrocracker and then you've got a brand new engineer on your team who's only worked on your wastewater treatment system, that just isn't going to fly. It's not going to be a good use of time. And instead of having a robust and worthwhile effort that provides good quality results, you're going to end up wasting a lot of time and maybe even having to redo it. And of course, at the bottom, somebody knowledgeable in the PHA methodology. We're applying hazard and operability studies consistent with a lot of experience base that we've acquired, and also it's consistent with CCPS guidelines for hazard evaluation procedures. This is the mainstream of activity. However, as engineering consultants in the area where we get out and help a lot of people with HAZOP studies, we see all sorts of applications that'll your eyes will pop out. You won't even, in terms of what people have done and called it a HAZOP study or called it a PHA. You've got to have somebody who knows the methodology, and we talked in the last course module about using endorsed methodologies, so that you've got an analysis that's robust and meets regulatory requirements. Key people on this team, as I mentioned, you've got to have a process or project engineer, operations, maintenance, and a PHA facilitator. Those are the ones in blue. They've got an R after them as required by regulation. These are the core members of your team. But if you're organizing this and you're facilitating a hazard and operability study, you've got to make sure that you've got the expertise that you need to get the job done. A larger effort, you'll also want a team recorder or scribe. We'll talk about that in a second. They can be pivotal to making the team sessions go smoothly and maintaining momentum. An instrumentation specialist may be needed. Safety and fire protection experts and other expertise may be really critical for your PHA team. Based on the objectives, you have to decide what you need. Also, optimal team size. Sometimes it's tough getting an operator and an engineer at a plant site who's got time to sit through these. That's a minimal amount of individuals. That's even a little on the small side. You usually want an optimal team size of 6 to 8 people with various expertise and people who have the horsepower in project management or in operations to endorse projects or give valuable insights. If you get too many people on the team, they spend a lot of time interacting, they bring other agendas on board, and you have a harder time reaching consensus the more people that you bring in. So unless somebody has specific expertise that's needed, they really shouldn't be present for these PHA team sessions. I have had sessions that have looked at very acute, very critical processes that had a lot of people's attention. I've had upwards of 30 people in a HAZOP study. It's very challenging trying to manage that, trying to reach consensus, and trying to move that forward. So unless somebody really needs to be there, you just don't want them as part of the team. Key team members, their roles, the facilitator. The facilitator has to organize. They can have good technical knowledge. In fact, we'll talk in a few minutes. It's actually very important to have good technical background. But their primary responsibilities are to organize and push the team towards finding those vulnerabilities or weaknesses if there are any. The facilitator usually ends up, because they have the vision for what has to happen and for the job to get done of preparing, they have to be the ones honchoing that, make sure the objectives and guidelines are met, scheduling, location of facilities, team selection, all the things that we've been talking about and are going to talk about a little bit more. The facilitator needs to provide team training. When you get a fresh team, you don't know what kind of hazard and operability study approach that they've seen before. They need to make sure that you need to make sure that they understand the objectives, and all these things are conducive towards making sure that you can maintain schedule, keep momentum. If you spend too much time on things, you find that the team just goes brain dead. They zone out. They're not contributors. Maintaining momentum of the sort where they can really think, flush out potential issues is a critical job for the facilitator. The facilitator can also support tracking of actions, and also qualifications, experience, and background. And training, of course, are critical to make sure that you've got a robust and high-quality PHA. The facilitator also is watching what recording or scribing gets done during the session. That's very important. The facilitator has to think ahead so they can guide the team towards reaching a conclusion. The facilitator has to be dialoguing with the team. The facilitator also has to look at what the scribe is recording to make sure at least it can be deciphered later in terms and to make a good quality PHA documentation. This is very challenging. You want to have somebody who's very comfortable working with groups and able to reach group consensus and be thinking on these many different levels all at once. Follow-up efforts may also be part of a facilitator's job. The facilitator must allow and encourage technical discussion and maintain progress. You got to keep that momentum going or you're going to lose people. Some people's philosophy is, gee, let's give them all the time they want. It just doesn't work. They zone out, they take phone calls, they start typing on their BlackBerry, anything but focusing on what they're doing. You want to engage them, you want to engage them in what you're doing. And that's a critical job for the facilitator. It's a lot of work, it's very energy intensive, it requires a lot of expertise, and the last thing you want to do as a facilitator is not be prepared and be trying to organize this thing as you're trying to make progress. What is the scribe doing? Well, the scribe, a lot of people go, let's just grab a secretary. Well, the fact is that they have to be qualified, they have to understand what the team is doing. They're going to be translating all these discussions into the documentation. Now, does the team notes, is that the final documentation? Usually not. Usually you want something that is a little more robust. You're double checking tag numbers and making sure that quality is there so you can understand and decipher it later in case you need to do updates to support your management change program or future revalidation efforts. So doing a good job on this documentation and having good quality scribe is very important. Other experts that are going to be there, they have to have suitable qualifications and experience. Like I mentioned before, you don't necessarily want to get somebody from another process unit that has no idea what you're talking about. That's not going to be helpful, and you're just going to have a lot of follow-up items, and you're going to be spending a lot of time trying to sort through things that you don't understand about. What about vendors? Well, a lot of times you get skid-mounted packages, as I mentioned lube oil before, where it's very simple, how many lube oil systems are there out there? People should know how to design it. The objectives of the project, you have to decide, gee, do we want to do an in-depth evaluation of that, or do we want to trust the vendor to give us a package that's very reliable and has no weaknesses in it? Well, my experience, that's basically you have to decide on the objectives. And the regulations, the guidelines allow you to make that decision. My experience is the vendor packages usually do deserve some attention. Almost, I think 100% of the time when we've gone through vendor packages during a HAZOP study, we found vulnerabilities, issues that can cause major equipment damage or major safety problems. And a lot of times this was news to the vendor because they design it for reliability. They haven't necessarily looked at it from a how can it break standpoint, which is what you're doing from a HAZOP study. Given that other perspective on things gives you a whole new set of insights. And so you have to decide whether you're going to look at vendor packages. But if you are going to look at them, you need to have people there that can address the design issues and answer questions properly. It doesn't do any good for somebody to just grab the vendor package information out of the FedEx pouch and walk into the HAZOP study. If you're going to evaluate it, you have to make sure your process engineer has reviewed it, understands it, and has asked the vendor challenging questions. If the process engineer hasn't done that or isn't willing to do that, you may want to involve the vendor by phone, by video, or have them physically present during the HAZOP study, or at least that portion of it. And also, we talked about the process engineer who may not understand that they have to respond to vendor questions. All participants need to understand what their roles and responsibilities are to make sure that they can support you properly. You may want to send them a sample HAZOP study so they can get a flavor, if they haven't gone through a good one before, of the kind of questions that will be asked, the kind of challenges they're going to receive. So after you pick the team and get the right people on board, just so it's calendared, you want to pick a venue. Getting the right location, someplace people can get to, someplace where they won't be interrupted every 5 minutes by other people asking questions, cell phones, et cetera, et cetera. It's very important, and it may need some upfront time. You want to make sure you comfortably accommodate the team and any visitors that may come in occasionally. Again, something to be minimized. And have ample table space for a working meeting. You don't want to just set up a bunch of chairs in a room as if they're watching a movie. They're going to actively participate. They'll have design information, engineering drawings, etc. They're going to be critical to support your PHA. Here's just a diagram of a typical room setup. This is a setup that seems to work out pretty well, and this is how we've set up our training center / HAZOP study room, which is where we're broadcasting out of right now. And this environment allows for interaction. You're looking at the other people. People don't get lost very easily. The blue dots on your left, whether it's left or right, the facilitator and scribe on one side and with the facilitator near the screen, so the facilitator can get up, get people's attention, point to things on the screen. Those are all really helpful. And again, you want to arrange the team. Where people sit can often make a big difference. If you've got somebody who's very outspoken or your key player, maybe it's the main process engineer who's got a lot of operations background, so you know they're going to be contributing a lot. Maybe put them on the other side of the room so that that'll help draw in the entire table for discussion and get all participants. People who are not there to observe. They're there to participate. They are there to share insights. They're there because they've got some expertise that you need for the PHA. And so for that reason, you want to encourage dialogue. You want to encourage participation. Step number 5, getting key information together. The focal points for PHA, because you're going to be looking at design and key design information, are your piping instrumentation diagrams, your P&IDs, and also process flow diagrams. Their accuracy, doing a good job up front, is critical to the success of the HAZOP study. Let me repeat that. The accuracy of P&IDs and process flow diagrams is critical for the success of your process hazard analysis. People need to, they can't just grab the P&IDs from 5 years ago and go, let's go HAZOP. Somebody needs to field verify them, make sure they're up to date, make sure they're accurate, or what you're going to do during your HAZOP study, instead of uncovering weaknesses and using your expertise effectively, is you're going to be having a ton of discussions about, gee, is it like that now? Or I thought we removed that tank 3 years ago. Those kind of things really can derail a HAZOP study. I've been in HAZOP studies. The drawings were promised were correct. I was told they were field verified. And I'm asking questions, and we're documenting things. And 10 minutes into it, I'm looking, and they're just blank stares. And somebody finally says, we removed that vessel 2 years ago. And these kind of things are just it's unacceptable waste of time. It's unacceptable if you're trying to achieve a quality PHA. The facilitator really should look at the P&IDs up front, making sure all the key design information is there, such as design pressures, such as set points, things that Judith is going to talk more about in a few minutes. One other way to do that is, if you're going to get the drawings at the last minute, which happens a lot for a design effort, is make sure that you give them examples of what a good P&ID looks like, so that they will make sure, if it's not, that they'll get it fixed up properly. Information needs, you may need to arrange for confidentiality agreements to make sure that you can get access to the information. You may have different people from different companies that can provide a lot of logistical problems with respect to information accessibility. Key information should be available in hard copy and also electronic form. You may want PDF files for somebody to flash on a screen. We'll be talking more about electronic communications, but having both forms of that to provide you with versatility can be very helpful. This is a nice little checklist of what I call desirable information, or things that you may want as part of to be present in the room or make copies of for the individual team members. P&IDs are fine. As I mentioned, accuracy is critical, but I will give you a little tip. If they're not 100%, if there are minor differences that you can clearly communicate during the HAZOP study, let it go. Go ahead and have a master copy on the wall of large-size drawings, mark it up, have the process engineer mark it up. Everybody can look at it, understand what the little change is, and factor that into your HAZOP study, and then have those drawings become part of your documentation. That's an acceptable way of doing things. The proof of the pudding is, can you uncover vulnerabilities, and are you doing a good, thorough job? Also, the H means high priority. On the second bullet, all these H's are high priority. Process flow diagrams. Other high priority items are site layout drawings. Even more importantly, for older facilities, we find a lot of interesting insights when, after you go through the cause-by-cause HAZOP study, we do an overall fire protection review by laying out the site plan and talking about, well, if you got a major fire here, you have a major fire there, where are the monitors, where are the evacuation points, where are the safe assembly areas, and site layout drawings really help a lot with that. And for older facilities, the paradigm of good practice changes over the years. And so for older facilities especially, you're going to find that you may find significant vulnerabilities just with a good thorough inspection of your site plot plan. Accident history and reports may be very important. You're supposed to be looking at that for revalidations especially, and also for fresh HAZOP studies if you're doing it on a new unit or you're doing it on an operating unit. Management of change, pre-start safety documentation may be important. Previous PHA recommendations may or may not be closed, and those are important to review. It provides a good value for the facility to run through those and verify what their status is. Equipment data books, operating and emergency procedures, maintenance reports, system descriptions, previous PHA reports, physical properties, chemical properties, and also compliance audits may also be very helpful, and you may also want those available during the team sessions. So those are a lot of the key information needs that you'll want to have requested and gathered and have available as part of your preparation activities. Step number 6 is equipment. Basically getting all the pieces together so that things work and you have all the tools that people are going to need during the sessions. One of the considerations is electronic. One of the things that's happened over the past few years is when you're having a tough time getting busy people, the people that you want for your HAZOP study together, a lot of times electronic communications, a couple of the packages that are out there, GoToMeeting, WebEx, you've probably seen those advertised. There are a number of other packages. They can be used very effectively to get groups in different physical locations, and we've had a lot of success running very good HAZOP studies, great quality by setting up interactive video, interactive computer screens that everybody can see, and also you may even run 2 at once, one to look at the P&IDs, one to look at the HAZOP study session notes. So there's a lot of things, good things you can do that are out there. However, beware, this involves computers. Computers always look for opportunities to foul up, and it involves technology, it involves bandwidth, internet connections, and a lot of logistical items that you want to make sure get prepared up front. This is one, especially if you're trying to arrange something like that, you want to make sure all of the I's are dotted and T's are crossed with respect to the details needed for setting this kind of system up. And also internet accessibility. Even if you're having people physically present at a HAZOP study, more and more people like to be connected to the internet on a 24/7 basis. They like to be able to receive cell phone calls, emails, et cetera, et cetera. It can be helpful if it's not overdone. People need to be focusing during a HAZOP study. It's kind of really nice if somebody's got a question and they say, wait, I'll send a quick email to my counterpart back at the office and he'll have an answer to us within 15 minutes. That's really helpful. People who spend time just reading their email and doing other activities and detracting their focus on the HAZOP study, that's not good. You may either want to pull the plug on it or ask specific individuals to leave. Things that you do want in the room, here's a little handy checklist for things that you want there. You want engineering drawings, large ones mounted on the wall, as well as individuals having copies is usually pretty important. LCD projectors. Having people looking at the session notes will give them a comfort level that you're at least capturing a lot of the key issues and insights that they're putting forth. And of course, you'll need a screen to project that information from. HAZOP studies, very few of them aren't being done without an LCD projector displayed so that all the participants can look. That's especially important if you're in a part of the country that requires regulator involvement. Regulators like to monitor PHA sessions very carefully, and being able to see what's going on and what's being documented is critical to their ability to endorse what the team is doing. The scribe needs a computer, obviously, to take session notes, to run whatever software you need for the tools, and also you may have design information, if it's available electronically, that can be displayed for the team. The facilitator, whenever I facilitate, I have at least one computer. I'm taking notes. It's a lot. I find it a lot easier to not lose them if they're on the computer. I also keep track of parking lot issues. What's a parking lot other than a place where you put your car? A parking lot is a way to avoid people spinning their wheels. If you have an issue that you can't easily address, maybe somebody needs to go out in the field, verify configuration, look at other design information, talk to some other individuals, but they think they can get it done before the PHA is done, go ahead and write the action on a parking lot. At the end of the HAZOP study, whatever parking lot items haven't been addressed, maybe they were busy, maybe they didn't have time, maybe they couldn't get the right resources, whatever doesn't get addressed gets translated into a recommended follow-up action. But a parking lot that everybody can see, whether you do it on a computer or a flip chart, is really important. Also, when I'm facilitating, I like to keep every break time, I'll ask for an updated HTML imprint or some sort of output from the HAZOP study software so that I can flip through it, I can do word searches, I can use it to maybe think ahead a little bit or verify what was discussed, that something was already discussed, to avoid having to have the team dwell or have any downtime for the team. Also, things that are handy in the room, food. Okay, a lot of people go for the food. You've got to have refreshments so that people don't wander off and go, like, walk a half a mile to the nearest coffee cart or the nearest roach coach at your facility. Having lunch there. If you let people leave, you may not get them back when you want them to be. They may get delayed, traffic problems, maybe the service was bad at a restaurant. It's much better to have food brought in, keep your team there so that you can make good use of their time and get the job done. When it all comes down to it, if you're facilitating a HAZOP study, being Mr. Friendly doesn't work. You've got to drive the team to a conclusion, keep them busy, keep them active, keep them moving forward, because when it's all said and done, if you schedule a certain time period for this and you're not finished, they're not going to remember how nice you are. They're only going to remember how awful it is that they have to reconvene the HAZOP study to finish the job at who knows what time. Flash drives so you can share information are also very important. Flip chart or whiteboard to take notes. Maybe keep your parking lot there if it's something that you want to hang on the wall. Other reasons to have flip chart, usually very helpful. Spare power strips if you're traveling, you don't know what you're going to get into. Having a sign-up sheet, bringing one so that people can so you have a record of who attended. And also highlighters. People usually come to these things with a blank sheet of paper. Give them the tools they need, pens, highlighters, whatever, so that they can take good notes and work with their engineering drawings. A little bit more about the LCD projector and general pointers on that. It's very useful for team notes, and also you can display engineering drawings. It allows the team to focus, but even though you're still going to have time afterwards to updating it and getting their comments after you send the draft documentation to them for their optional review. It also helps the facilitator. It gives the team something to focus on, which is very important. If the team is starting to have a lot of sidebar conversations, if I'm not already standing, I'll stand up, walk to the screen. That in itself tends to draw people and get people's attention and get them back on track. And also, but you want to make sure that the only person who does this is the facilitator. If you get people who are a little bit too anxious or trying to take control of the meeting and also try to jump up and do that, that can be very distracting, and you may need to have a discussion with those folks outside the room. It's a very useful tool for the facilitator to use to maintain team progress. One disadvantage that's controllable is for people who want to wordsmith it or do too much of the documentation at the time. Like I said, that's controllable, and also if you're moving fast, that'll kind of prevent that. So step 7, I call it HAZOP study readiness. There's a lot of old school facilitators who will just like show up, and it's their job to understand how to do a HAZOP study, and they just want to push the team through it. That just doesn't work in my book. There's a lot of things that you can do up front before the HAZOP study, and that's what I encourage all of our facilitators at Risk Management Professionals do, is to prepare well to make sure that you make very good use of time and really push them through this and get a lot of value out of the HAZOP study. Technical readiness is key to success, in my opinion. Showing up without being ready as a facilitator just doesn't cut it. Key things that the facilitator can do to really prepare technically and get the team moving is noting it out up front. You know, just showing up with a blank sheet of paper and saying, okay, team, where do you want to draw the node boundaries? everybody's going to have a different opinion, and you may have some opinions or may get forced into a consensus solution that really doesn't make much sense. Defining the nodes up front, but allowing the team to comment on them or modify them is very, very helpful. We'll talk a little bit about highlighting and PDF copies and whatever. There's a lot of tools now that allow you to have electronic copies of highlighted drawings and even overlay them with CAD so that it can provide a lot of good value for the documentation. Design intentions, a lot of people tend to overdo that. At least having a template up front and preloading them into your HAZOP study software is really helpful. Deviation matrix, making sure that's addressed up front. Showing up to HAZOP study with just a, hey, let's talk about some no issues and some process parameters, let's put them all together, that just doesn't cut it. You want to define them, you want to load them into the software, you want to have a fairly abbreviated deviation matrix like the one that I displayed just a little bit ago. In fact, I think I got another copy here pretty soon too. That sort of thing helps the team focus. You can always bring in some special issues. Usually at the very end of a node, I have like a general deviation where you talk about other things that the team wants to discuss. Defining key consequence categories up front and deciding what the level of detail you want to do for operational issues is very important. Having the team spend a lot of time on a very low consequence, frequent event that doesn't really do any harm to personnel, to the environment, just doesn't make a lot of sense. You want to have them focus on high-risk type issues. So if you've got an operational issue, if the team's willing, just call it, hey, this is an operational problem, and not go through all the safeguards and all the other issues associated with this unless it really truly represents a weakness. If there are other shortcuts that the team agrees to, such as not talking about car sealed open valves being inadvertently closed, that's fine. Most teams will buy into that. And if you do discuss it, if you start talking about a valve that's ordinarily locked open or car sealed open, and start talking about it closed, and they identify a vulnerability, what's the action item? The only action item out of that, or at least the first one, is they'll say, well, let's make sure it's locked open. And so if it's already locked open, you're really going nowhere but in a big circle and wasting time that could be used to look at potentially important vulnerabilities. So if there are shortcuts like that that the team agrees to, that's a good thing to define up front. Also, getting the computer all set up, preloading it with deviation templates. If you're also doing LOPA, the segue to the LOPA so you can link the two, data tables preloaded into the layer of protection analysis software, all that can be really critical. Making sure the risk ranking matrix is preloaded. Also, what we like to do is get key causes preloaded. Looking up front at the facilitator and or the scribe up front, looking at the drawings and identifying key control valves. You want to make sure you look at their being closed as a potential causal event. Ruptures in heat exchanger tubing, relief valves opening. Basic things preloaded can help provide a structure that you'll be able to easily update for the next 5-year revalidation. And also, it'll mean that key things are going to get covered. You don't necessarily have to reinvent the wheel in each case. And the team can focus on the things that may be a little bit less conspicuous. Maybe some subtleties that somebody from the outside, the facilitator, may not have noticed. So preloading causes can provide a lot of benefits and save a lot of team time when it comes down to actually doing the team sessions. Also, another tip, the first day, something or many things are going to go wrong. Equipment, room setup, there's another meeting there, you have to go to another room, whatever. Get there early. Leave time for problems, for setup. So if you told the team that you were going to start at 8 o'clock, be ready at 8, make sure the software, all the physical items, everything else is ready to go. After the first day, it usually gets a lot easier, but that first day, leave time for problems. Other preparation activities for technical readiness is if you're a facilitator, make sure if you've got checklists for those types of systems, industry guidelines, that those are available. Also, to avoid problems, if you're trying to track somebody down, a key person who isn't at your session, get their cell phone up front. As part of the preparation, get cell phone numbers for all your key players, anybody who's responsible for logistics, so that if there are last-minute problems, you're ready. You can deal with it very easily. Key handouts, training materials. One of the facilitator's responsibilities is to train the team, including human factors and facility siting key points that you want the team to look at. LOPA data tables may be good to hand out, risk ranking matrices, and of course, the core part of what you're doing is accurate P&IDs and process flow diagrams. For a typical setup, even though large engineering drawings are easier to read, you just aren't going to have the table space with a big team. 11 by 17 copies work very well, and if it's possible, pre-noted, well actually, usually teams will like it if the facilitator pre-notes it. And if you're doing it electronically on a PDF file, or PDF files are really easy to overlay with highlighting. AutoCAD, you can also put in a layer for highlighting. Printing those out, the team usually likes that too. And they appreciate the fact that you've prepared and you've done a lot to make their job easier. Also, key facilitator preparation issues. Again, the facilitator doesn't have to be responsible for engineering expertise, but reviewing the drawings up front, knowing the process, maybe asking questions of the key process engineer, that's going to be super helpful so that you can do your job as a facilitator to guide the team, think ahead, and push them in the direction where they need to go to get the job done for looking for those potential vulnerabilities. I definitely do not endorse the old school approach of, you know what, I'm just a facilitator, I'll ask the no flow, more flow questions, and the team has to do everything. The team is responsible for that. You as a facilitator are responsible for guiding them, but you can guide them better if you really know the process, or at least are fairly familiar with it by reviewing the technical information up front. Noting, we talked about nodes being as large as possible is usually very helpful, and also provides a framework and a starting point for the PHA team. They can look at it and not have to worry about where the boundaries are. They can be ready to go. Cause definition, we talked about the advantages to that. Also combining causes with identical consequences. If you've got a series of valves, go ahead and put them in the same causal event and just use the most limiting likelihood. If a control valve is bounded at a control valve station by 2 block valves, look at the causal event as the control valve fails closed or the block valve is inadvertently closed, and there may be instrumentation associated with that too, so you may want to say, or possibly due to a failure of the level transmitter, for example. Combine this together because you're not going to have new insights. You're just going to be burning team time by separating those apart. Also, if you're doing some fairly familiar equipment, whether it be a push-pull system on a blanket gas for a feed tank, or whether you're talking about, let's say, a lube oil skid, get something, if something is real close that you've worked on before, go ahead and preload that. The team will appreciate the fact that you're drawing on insights and they don't have to do everything from scratch, and they can focus on the hard stuff. Node selection tips. This is really important for getting the team started. Basically, defining it before the PHA session is really good. Typically, it's where the feed enters the plant and then following the process through the product, leaving the facility, including major vessels or equipment, covering auxiliary systems in separate nodes, and making the nodes as large as practical may be good ways to approach a lot of different things. I wanted to give you a couple of good and bad examples. Here's a good example of node selection. On the left, you see a blue process vessel that's feeding the suction of a pump through a heat exchanger, a level control valve into another vessel. Well, when you're going through a HAZOP study, you remember the deviation matrix. You're looking at no flow, more flow, high temperature, low temperature, high level, low level. Well, the blue area really encompasses all that. You're kind of looking at the same process area, and so keeping the team in that area and thinking about it from a fairly holistic perspective as you're going through the deviation matrix will make sure that they can find things later easily to update it, and they're not looking at the same kind of thing over and over and over again. For example, if you were to split the blue area into 4 different nodes, and you start the first one with the process vessel, and you start asking about high and low levels, well, when you start talking about the next node, which might be the pump, having failed to operate, you're going to also talk about that as maybe having a high level consequence. or a high-level result that may lead to problems. So by splitting it up too finely, you're going to find yourself being very redundant in terms of the questions that you ask. So the blue area, keeping all that together, is a good example of how to make a node. Like I said, if you were to split those areas into different pieces, this would be a real bad example. It can lead to a lot of redundancy. And the worst thing about redundancy is you can ask a similar question to a team where they should be giving you the same answer, and they may give you something totally different. And especially if you haven't prepared properly or understand the system, you may think that they're talking about a different type of scenario. So understanding the system, good node definition allows the facilitator to pull all this together and make sure that the team can focus on things once and do it comprehensively. This is a fairly complex example that actually worked well for one of the HAZOP studies that we did. This is the front end of a hydrotreater. Basically, you got a feed tank going through a pump, flow control through a heat exchanger, heat recovery exchanger, through a main heater, heat H-1, through a reactor, and then you're taking the reactor effluent back to the recovery exchanger. And here on the feed tank, you're also having a push-pull system to control the pressure of the blanket gas. This looks very complicated, and you first look at this, you go like, why would you make one node out of that? Well, the reality is for these types of processes, because you're dealing with high temperature, high pressure situations, you really don't have a lot of active components. And that's typically what you look at for a HAZOP study is active components. So by grouping this one flow stream at the front end of the hydrotreater as one node, basically you look at the high pressure, low pressure deviations and cover your push-pull system on top of the feed tank. You look at high level, low level when you're looking at the pump itself, the flow control valve, those types of active components. You may look at temperature excursions in the reactor or issues associated with the heat recovery exchanger and heater 1. So all those things are pretty much encompassed by a holistic discussion, and this will work very effectively for something like a hydrotreater where you're dealing with a single flow stream and very few active components. You'll notice on the heater that the firebox and main heater controls are in a different color. I believe it's orange. Those make a good separate node because it's a very complex system that involves a lot of active components, and you've already looked at the impact on the process in the first node. Other node selection tips, I'll just throw out my own 2 cents with respect to colors. Minimizing the number of colors that you use. If you make them too small, if you use like 2 highlighters, you're going to get a lot of mix-up for the nodes. But a lot of people with a lot better color sensitivity than my eyes will use one of these highlighter packs with 10, a dozen colors. And especially after it's aged, or you try to pick it up for revalidation, or especially after it's Xeroxed, or even if it's scanned, a lot of those differences or things that you might have looked at when they're fresh get totally lost, and you may be looking at a scanned copy 5 years later for your revalidation, and you may not be able to see the difference between aqua green, I don't even know a lot of the colors, but like an aqua color or a light green or something like that, and it's really not going to be that helpful. So having a set of colors that are very distinct is very helpful. And also, for documentation purposes, if you're going to do it, if the facilitator is going to highlight it and note up the drawings, doing it up front with a PDF file or in a CAD layer can be really helpful. I mentioned also, I was going to show the deviation matrix again. This is a good example of one that's very functional. You notice that it focuses a lot of things. We tend to do flow up front. In fact, no flow covers a lot of the key issues that are going to come up. And then if you get to a temperature excursion and you've already looked at the effect of a no-flow case that caused that temperature excursion, why do it again? If you did it right the first time, just go ahead and reference right back to it. And so having a set of guide words that's very functional, covers a lot of the areas. This is a good example of one that works very well for us. Other resources for the previous course module, I also provided consequence examples, risk ranking matrix samples, also generic issue examples and global issue examples that you can also reference and bring into your HAZOP study. And also what I wanted to provide in terms of tools and reference materials, this isn't a preparation step. This is just a little added bonus to you guys. What you're going to find as a facilitator that the initial training materials are good, but some people don't think well in terms of failing the system or having a component malfunction. They think more in terms of the system working properly. A lot of people have trouble thinking about the ultimate consequence concept, where you're not thinking about safeguards, and then you bring the safeguards later and document them so that you can identify if there's some potential vulnerabilities or other safeguards that you need. So I find it at least daily, and for some teams almost every other hour, I have to give them a little refresher. And so here's my little 2-page refresher where I provide the team with a little update just to keep them synchronized and keep them on track. So anyhow, this is for you to use. I find this very helpful to do at least once a day, and like I said, for some teams, a lot more often. We talked about all the different preparation steps. Let's talk about timing. You may need a lot of lead time for these kind of things. Defining the objectives and scope up front. Sometimes you want to do that 7 weeks or more up front so that you know where you're going and can start asking for the right kind of information, because it will take time to pull all this stuff together. Team invitations and scheduling usually is 6 weeks. Stipulating the tools to use, figure that about a month beforehand in case you need to arrange licenses. Getting the venue up front, maybe about 4 weeks before to make sure you get the area that you want. Getting key information after you've decided on your objectives and requested it. You should be compiling this at T-2 or 3 weeks, or else you may have a lot of last-minute problems. Arranging for equipment, begin preparing the PHA elements, usually a couple of weeks beforehand, and so you're ready to go when you get your team together so you can have a good, effective PHA. Now, given the fact that this is a webinar and we're not going to make this interactive, I just want to kind of go over some key points in the form of a quiz that we would normally give for people who come directly. The first question is, the optimal PHA tool technique can change based on project objectives or type of system. Absolutely true. The tools can change depending on what the needs are. Scheduling the PHA team can be left to last. Second question. No, that's absolutely false. The team is either going to make or break you. Having the right people on board is super important. Inexperienced personnel can be key participants in the PHA because you've already got all the necessary information in the PSI. True or false? Absolutely false. You need to make sure that the people have the expertise that you need. Having a new engineer is fine. If they need some support with a senior person, make sure that senior person at least is coming in and out or readily available. Including a scribe on a PHA team is optional. It is true. There's no regulatory requirement for a scribe. You've got to gauge whether or not that scribe is going to help keep the team focused and keep you moving. And in most cases, the answer is usually yes, that it will be very helpful. P&IDs can be outdated and inaccurate. False. If you're starting a PHA and you see the last revision was 5 years ago, it should be signaling alarm bells, and you should be having somebody field verify it, make sure it's up to date. Little changes are okay during a HAZOP study, but anything of substance really ought to get worked out up front. Since the process engineer is present on the team, the facilitator does not need to have any technical background or capabilities. Now, you'll see differing schools of thought on that. My experience is absolutely false. The facilitator needs to be prepared. The facilitator needs to have reviewed all the technical information up front and be ready to go. Now, there's a couple of what I wanted to do. Actually, we're going to do this after we give some podium time to Judith. The next few slides are going to be focused on a group discussion of PHA Preparation Challenges. We'll bring that all together after Judith finishes, and maybe do a little mini workshop too. So let me go ahead and introduce Judith. Judith Sakairos is, we'll be starting on Module 3B, Nicole, just so you know. Judith Sakairos is a senior engineer at Risk Management Professionals. She's got her bachelor's degree in mechanical engineering at the University of California at Fullerton, and she's been a key part of our team doing both onshore and offshore work, and does an excellent job keeping a HAZOP study moving and doing a good job with facilitating it, and is our reference point for good quality P&IDs. So anyhow, turn it over to Judith.
Nicole, is my audio on? Yes. Okay. Good morning. So we're going to start off with a definition of the use and importance of P&IDs, and we'll define the topics. Give me just 1 second.
We're having technical difficulties. There we go.
Okay, just forward and back, Steve. Oh, okay. All right. So we're going to first define the topics that we'll be going over, and we'll be touching on the use of P&IDs, key elements, importance of high-quality P&IDs during a HAZOP study, and also signs that the P&ID has not been field verified, and how to actually prepare for that not to happen. Use of P&IDs. So the purpose of a P&ID essentially is a representation of the process or system and how it functions. You're going to depict the sequence between components within the process. It also provides information on instrumentation and equipment interface. What P&IDs are not, they're obviously not going to, provide you with the physical representation of the system. So, two items side by side or two pieces of equipment side by side on a P&ID may not be out on the field, side by side. They can be on opposite ends of your site. And so the essence of the P&ID, as we all know, a picture paints 1,000 words, and the P&ID is kind of like the language for communicating and defining a process. Utilizing P&IDs specifically for a HAZOP study. So they're definitely a useful tool during a HAZOP study. You want to have accurate P&IDs. You want to have fully developed P&IDs, because what this does is this enables the team to understand the process. When you're in a HAZOP study, as Steve mentioned quite accurately, it can be a challenging job for a facilitator to keep the team focused and keep the HAZOP running smoothly and keep the information valuable and useful. And whatever stage you're at in the HAZOP, whether you're doing more of a HAZOP light or a detailed HAZOP, having complete P&IDs will enable you to document properly and make sure that down the line it's still understandable. So it definitely enables the team to understand the process and keep the HAZOP moving smoothly. It allows for systematic evaluation based on the representative P&ID flows. So this goes back to what Steve was saying about node development. If you actually node out your system and you have high quality P&IDs, this will enable to keep the team focused and aligned. So because you're focusing them on a portion of the system when you node the P&IDs, if you have the P&IDs available, you go ahead and you node it out, whether it's beforehand on PDF, using the highlight and structure your nodes out so that the team is all aligned as to what portion of the system you're looking at. This helps really focus the team on where you're at and, prevents, deviating downstream or upstream, and really helps to focus them on the portion of the system you're looking at to develop scenarios. And then also to, as part of training, when you define the nodes, also communicate that your consequences during your HAZOP are not limited to that node, and just keep pushing that idea. So it also helps you to, for facilitators to organize your thoughts and keep the team focused, and also as a training mechanism to, promote how the HAZOP study functions, and when you're looking at the node and when you need to be looking upstream or downstream of the node. Valve equipment identification tag numbers, these are really critical for high quality P&IDs and utilizing them during the HAZOP, because this promotes your synchronization between what the team is evaluating, and obviously is going to be looking at your P&IDs when you're making the evaluation, and also between what the facilitator is referring to during the HAZOP and what the scribe is ultimately going to document in the HAZOP. This also identifies, obviously, when we're talking about the same thing, facilitates identification of safeguards. So if you have everything properly tagged, your scribe's going to be able to properly document the different tag numbers for the different safeguards that you qualify. And also, you know, later down the stream when you're looking back at the HAZOP, you'll be able to really understand what the team was referring to as a safeguard and documenting as a safeguard and where that's located on the P&IDs and obviously in your process. Process design and conditions defined in P&IDs are used to evaluate the process during the HAZOP. Okay. And a continuation of utilizing P&IDs. P&IDs are going to be your main component when you're looking at the HAZOP in that systematic manner of node definition, and then looking at the different parameters and looking at no flow, more flow, high pressures, low pressures, etc. But they are limited to the scope of what their intention is, and so during a HAZOP study, P&IDs can also be used alongside with other useful maps and diagrams for a comprehensive HAZOP. You're not going to clutter up your P&IDs with a lot of excess information, because then that would just be confusing and kind of deter the team from the usefulness of the P&ID. So what you want to usually do is have supplemental maps or other maps that can be used alongside. And these can include process flow diagrams, so your PFDs, and they're a more general outline of the process flow. They're not going to include, as Steve kind of touched on, the major, it may include some major controls, but it's not going to include all the controls and all the valving and all of the detail that a P&ID has, but it's more to give a comprehensive understanding of your process flow and more general view, so that people can kind of visualize when they're looking at one section of a P&ID. They can refer back to the PFD to get the general understanding of where they're at and what impacts are upstream and downstream. Cause and effect diagrams are a very useful tool for more complex processes, depending on what system you're looking at. If you have a cause and effect diagram, what this is it's supplemental information to what you have on your P&ID. So on your P&ID, you're going to have certain interlocks and trips that are issued, and you'll have the tag numbers if you have a good P&ID on there. And so the cause and effect diagrams can be used alongside to further explain what those interlocks or trips, where they are, what equipment is affected, so that when you're developing the HAZOP scenarios, you can properly identify what exactly are your safeguards and what equipment is affecting, what your trips are going to actually shut down, etc. So you also have electrical diagrams. These can be useful alongside with P&IDs during a HAZOP study, simply because if you're looking at power outages, if they're full scale, or maybe just you have partial bus failures, and you're looking at you know, a pump failing and you have spares, things like that. If you understand your electrical system, then you can better explain a consequence during a HAZOP. You can fully evaluate the impacts and determine whether your electrical configuration is satisfactory. Site maps can be a very useful tool in the sense that you can couple these with when you get to your human factors or siting issues, because the P&IDs are more of a systematic flow of the process. If you have the site maps to really visualize where everything is at and how one thing can impact another in terms of the siting, then that really helps out to have those available. And also chemical detection and monitoring maps and their locations are, for obvious reasons, they're really good to have, because when you're defining your HAZOP scenarios and you're looking at your detection and the set points, if you have a reference as to where that's located, that can really provide some insight into your detection. Okay, and so we're going to move on to key elements. And so summary of the key elements, bulleted out, are general P&ID layouts, the legend, piping, valves, instrumentation, and equipment. Some of this is going to be pretty basic. We'll kind of just go through it. The P&ID layout, you have a grid. Usually is a good thing to have, especially if you have more of a complex P&ID where you have a lot of equipment, a lot of tag numbers, and because you want to keep the HAZOP study team really focused and keep things moving along, a grid is usually a useful tool to have on your P&ID just because you can, go A3 and it's kind of served up its own little matrix, and you can find yourself, if you're referencing to a tag number and you need to get the team synchronized quickly, then this is a good way to do it. Information blocks. The title block enables identification of the system and drawing numbers. For HAZOP documentation, this is critical because it's just going to be, if you have a 200-page HAZOP report, this is going to be, the basic of finding and navigating through that report. So you need to have, definitely understand where you're at in the system, what drawing you're looking at, and also what revision. So revision block provides information on history of changes to the process. We'll go over this a little bit more later on, but essentially this is key to identifying when it was last reviewed, what changes were made, and it gives a lot of insights during the HAZOP to understand where the process is, what has changed, and if any other revisions need to be made, or if this is not properly updated, that needs to be incorporated for future revisions. Because a lot of times, you make some changes, and it's easy to forget to change that. So it's good practice to just always make sure that you document any change and make sure that you add it as a new rev. Because what happens if you don't and you keep the same rev numbers, when you're looking at the HAZOP documentation and someone picks up, what's supposed to be rev A and it should have been rev B, now you have two rev A's, it becomes really confusing because tag numbers don't match up, your equipment may not match up, your lines where they're going to in the process don't match up, and so it becomes for a hard situation and a really confusing situation. P&ID legends. A legend is useful to understand a P&ID. It defines the symbols with corresponding type, piping type, equipment type, valve type, etc. So this is kind of your key. This is what's going to define what you classify as a control valve, how you depict it, how you, designate or what the symbology is for all your equipment, including exchangers, vessels. And every industry has different names for their vessels, and there's only a limited amount of vessels that we have or equipment that we have. But since you tend to find that in each industry, they'll call their vessels something slightly different based on what process is flowing through it. So a legend is really what helps merge all of this information specific to the facility and helps as a communication tool for aligning everyone. Because what happens with this is, during a HAZOP, if you have, you have the facility personnel, maybe you have the facilitator, you may have some contractors, and everyone might have an understanding of P&IDs, but may have their own interpretation as to how you designate a pressure relief valve. Do you call it a pressure safety valve? Do you call them pressure regulating valves? Do you call them pressure control valves? There's different equipment, and then there's different names for each equipment or piece of valve. And so having that legend really helps synchronize everyone and, oh, okay, I see what it is. And so when you're going through the HAZOP, it helps avoid misunderstandings between different personnel where it's just a matter of if you had a legend, then it really helps define and everyone's on the same page of what everything is. Piping. So piping, you're going to have common line symbols, and these are just going to define the differences, whether you're looking at existing process equipment or piping to be demolished, if you're looking at any heat tracing in your piping, and for your instrumentation, if you're looking at electrical signals versus pneumatic lines, and the connectors, obviously, where you're going to. This is for larger scale projects, the connectors and having them properly defined is really important to have, just because if, you need to know where you're going in order for the HAZOP study team to be able to fully define a scenario and understand what the process is and where it's going. So having those really clearly identified is critical, and should definitely be verified before, issuing these as the P&IDs that will be used for session. Line identification, so this gives you detailed information of the process, flow piping, and design specifications. And so this is critical so that you can match the piping to the service and the design limitations and specifications. Valves. The valve symbology, you're going to have different types, obviously, of internal mechanical configurations. And we're just going to outline some samples of some symbology. And again, your legend would be the one to provide you with information as to what it actually specifically means to your facility. And we'll see some examples of confusion in just a second. But you're going to have your gate valve, glow valve, typical ball valve, butterfly, needle valve, and there are different sample symbols. This is one example set. You can also have multi-port valves in your process, angle valves, check valves, pressure relief valves, and those are sample symbols. And another thing that should definitely be defined on the P&IDs should be the valve conditions. So whether you have a normally closed valve, normally open valve, a locked open valve, and a locked closed valve. And the reason why these are so important is because this really helps synchronize the team as to, why are these, for specifically speaking for the locked open or locked closed valve, why are these locked open or why are these locked closed? And also to help identify if there are some valves that are not currently locked closed and locked open and should be critical valves that should be evaluated before someone, thinks about closing or opening that valve. That should definitely be something that the HAZOP team can identify during the study and make a recommendation as necessary. So when you don't have these valve conditions assigned, it really just leaves the team open to not consider those considerations. It's easy to overlook that, but it could be something that is a very critical feature for the process. And mispositioning some valves will have a higher degree of risk than other valves. And so designating those and defining between the two is very important. Variants in valve designations. So here we just outlined a sample of how this actually works in conjunction with our legend discussion. We show here from the left to the right a closed valve, which can be considered the same as a normally closed valve, but depending on what P&ID you're looking at can be represented in the same manner. And then some things that we have seen have been like glow valves, third from the left, and then a glow valve also designated as what could also be considered a closed valve. So it's very important to have the legend so that everyone's synchronized and understands what it is that you're looking at when you're going through a HAZOP. And it also just helps keep the team focused, because if you don't have that, everyone's on different pages, this could confuse what the process flow is. People may have a misunderstanding of how the process is working, which then translates to a HAZOP study that's not very good quality, or a lot of confusion for the facilitator and the documentation purposes, getting to fine-tune a consequence if everyone's on different pages can be a big challenge. The valve failure modes are another critical item that should be designated on P&IDs. And so these are the fail positions that are common: fail closed, fail open, fail last, fail in place. And this is very important to have as well, because failure modes are one of the considerations during the HAZOP study. And what happens if you don't have this, just like if you don't have the normally closed, normally open designation on your P&IDs, if this is not identified on P&IDs, can also be overlooked, and this can sometimes be a very critical item. So sometimes it's pretty obvious what needs to fail open, what needs to fail closed. But if you have a control, midstream in your process, and maybe someone designed the fail open for considerations upstream, but necessarily didn't look at the considerations for that same failure mode and how it impacts downstream. And maybe downstream impacts are more severe if you have that type of failure mode. So it's very important to identify these failure modes, because what we're looking at during the HAZOP study is for these things. We're going to look at failure modes, and we're going to look upstream and also downstream. And that's where, if anyone didn't identify those, or when they were considering what failure mode for that, if they didn't consider all the possibilities and how they impact upstream and downstream, this is a place to do that. And you have the proper team members in order to make that evaluation. So having this information is very valuable because it can provide key insights into how your process is working and how failure modes will impact that, and also identify if anybody missed anything or if there was a consideration that wasn't made that can be identified during the HAZOP study. Instrumentation is going to be our next topic. The process plants consist of instrument loops or control valve assemblies, and they're designed to maintain a process variable, so pressure, flow level, temperature, within a defined operating range. And the control loop components include the sensor, transmitter, controller, actuator, all of which should be defined on your P&ID. And additional instrumentation that should be identified on the P&IDs for a HAZOP should be gauges, indicators, and recorders. Okay, and there's some sample symbols for the type of actuators. You can have solenoid, diaphragm, motor, piston, and it's important to have this on there because it's what the driving force is and can provide some insights during the HAZOP study. The instrument, logic, and computer symbols are a critical element just because this helps communicate when you're defining what your instruments are and what your controls are. It's defining where they are in the process. Are they at the source where the equipment is? Is it a distributed control system? Is it a PLC? And how are those signals distributed? So it's very important to have that and classify that on your P&ID so that people, when determining safeguards, when determining what safety systems you have in place, you can properly evaluate how those will help you during a deviation or to, if you have some sort of failure or you're going beyond your process design intention, how those safeguards will help you during that type of scenario. Instrument identification and tag numbers are important to have for communication on your P&IDs. And so you will have your instrument types. So if you have a temperature transmitter, there are certain symbologies that we'll be looking at samples of in the next slides. And the sequence tag numbers, you need to make sure that each instrument has its unique tag number to avoid confusion, obviously. And the instrument nomenclature, this is just going to be a sample, so you'll have your flow analysis, flow, level, pressure, change in pressure, temperature, etc. And so there's certain codes and nomenclature that you can use. And again, this should be defined in your legend. And it'll be for how we looked at the previous example. We had a temperature transmitter. So if you're looking at temperature, your element type would be T and transmitter T. Whereas if you're looking at a controller, it would be temperature controller, so TC. And so that's a sample of the nomenclature. You should have one so that you can properly communicate what type of instrumentation you're looking at, what that instrumentation is doing, and how that's controlling your process. Okay, more examples. And so an instrument loop example would be having your flow valve with your flow controller and your flow transmitter and having the appropriate line, that is sending the signal. So you have your pneumatic line with your electrical line going to your flow transmitter and your flow element. And if you have any interlocks, designating the interlock numbers, which is not depicted on this example. Going into equipment, we talked about this a little bit previously, and for your equipment, you'll have key process equipment, which can consist of accumulators, separators, reactors, fractionating columns, heat exchangers, air fin coolers, heater, compressors, pumps, and you may use some or all of these depending on what process you have and what type of process you're evaluating during your HAZOP. And you may have different symbology for it depending what facility you are. So this ties back again to the legend that it's important to have so that you can properly define what you classify as your equipment. Use and importance. Well, the importance of quality P&IDs during a HAZOP study is what we're going to go into. Okay. Accurate and detailed P&IDs what they do is they allow for high quality and efficient HAZOP sessions. And Steve touched on this somewhat, but just elaborating a little on some of the key topics, it enables the team to better define and evaluate scenarios. So it's because it serves as the communication factor, having highly developed P&IDs with the adequate amount of information really helps the team to identify what is there, and also focusing on the design limitations and improvement areas. If it's a very vague P&ID, it's hard to do that, and it's hard to come up with valuable recommendations. So if you have a high quality P&ID, you're going to have that valuable recommendations versus verify recommendations. If your P&ID is lacking a lot of information, there's going to be a lot of unknowns. The team's not going to be able to really develop valuable consequences or accurate consequences and safeguards, and there's going to be a lot of questions and a lot of assumptions, and those assumptions are ultimately going to result into recommendations that still need to be verified, and now we need to reconvene and look at this again. And so it's a combination of wasted time and a low quality HAZOP report that you get when you don't have accurate and detailed P&IDs. Key information on P&IDs enable the team to identify areas of concern that may otherwise be overlooked during the HAZOP study. So you have to keep people focused, and you have to keep the information valuable, and you have to make sure that you touch over everything when you're looking at the different scenarios. And in order to do this, you have to have comprehensive P&IDs. It's a common link between the HAZOP and process documentation procedures. So another reason why your P&IDs should be pretty fully developed and should match the different documentation you have is so that later on when you look at it, you can actually find a common link. Your process safety information is going to have probably equipment information, tag numbers. Your operating procedures that you referred to during the HAZOP study, oftentimes they're going to delineate your process and include specific process equipment information, and you use those as safeguards sometimes. And your mechanical integrity definitely will be evaluated during the HAZOP study, and what you do for each piece of equipment will be sometimes a safeguard. And so it's very important that your P&IDs, your SOPs, your PSI, your mechanical integrity, and all of your process information kind of come together and link together appropriately, so that you can define what are your risks and what are your safety systems in place, and how do they match up with all your documentation. What this does is it just prevents large headaches it gives you a high quality HAZOP, and it prevents large headaches as a result. Because if you have a high quality HAZOP, when you come back during 5-year revalidations, when you come back for management of change reevaluations, it's going to enable you to navigate easily through your HAZOP study and really understand where you are in the process, what the team was talking about, what they credited as safeguards, and what the recommendations mean. Okay. Key P&ID information for your piping includes pipe size, materials of construction, design conditions, specification breaks, heat tracing, insulation. And the reason why this is important is just because it's going to enable the team to identify the adequacy of the pipe for service and any special considerations such as corrosion, runaway reactions, and then changing process flow. So, if you're going to be making a change to your process flow, you need to understand what piping you have in that service, what equipment you have in that service, and how making any changes to that process will impact, and if there are any metallurgy conditions that need to be changed, and so forth. Equipment type information, you should have the type on the P&IDs displayed, the size, materials of construction, and the design conditions, so temperature and pressure, design, maximum pressure and temperature design conditions. And what that's going to enable you to do is just fully evaluate your scenarios, because if you actually don't include this information And there's a balance between how much information you want to put on your P&IDs. So you don't want to make it clutter, and you don't want to overwhelm the sheet with information. So you want to keep it limited to maybe the elements defined here. But obviously, having that information available and readily available during the HAZOP study for team members to look at and consciously consider as you're developing these consequences and your scenarios and what safeguards you have in place really helps for a high-quality HAZOP in the sense that it's keeping the people focused. And if there are any additional considerations, because now they've observed, something that may be cautionary, you can refer to other documentation. You can refer to your process safety information, and you can refer to any other cause and effect diagrams for further evaluation, and you can refer to these various documents. But having that information right in front of everyone makes sure that no one, that people are conscious of the design considerations. And because you're looking at deviations and failures during a HAZOP study and testing the upper and lower design of the system during these types of events, it's very important to have that readily available because, as Steve said, generally, process engineering operations, they're very much looking at, your normal day-to-day operation. This is what the equipment is designed for. This is what the process is designed for. And really, when you're evaluating HAZOP study, it's actually breaking up that and actually looking at, let's push this. If you get some failures, what's going to happen upstream, downstream? What is your upper design criteria and lower design criteria? And so it's actually a little bit abnormal into what is normally considered. And so it's important to have that equipment information because although for normal operation it's great and that's what the process is designed for, it's important to have that and really consider it when you're looking at these type of scenarios where you're going outside of the normal operation. Instrumentation and control information. On your P&IDs, you can include and define what your instruments are, what your controls are, and whether it's monitoring, controlling, emergency, if there's some emergency action associated with your controls, such as alarms or automatic actions, which could be shutdowns or starting or controlling a valve downstream. And it's really important to define that in the P&ID and show the appropriate instrumentation and how it all links together. And what this does is this helps define the process. It enables the team to verify the failure modes, and it enables the team to understand control interlocks. And so we just have an illustrative picture there of how we're utilizing the instrumentation, the nomenclature, the failure modes, what safety systems you have in place, and it provides a comprehensive picture of what's going on, and it enables the team to understand and properly document during a HAZOP. Safety systems information, relief valves, your flare systems, emergency trips and actions should be included as part of the P&IDs, and information on the settings and actions of the safety systems should be identified, whether on the P&ID or through supplemental information. Okay. And so signs that the P&ID has not been field verified will include, if you have an inaccurate P&ID, it's essentially an invalid HAZOP study because, if you have a missing piece of equipment, that's not going to be okay during the evaluation. And not preparing and not having those P&IDs readily available will surface pretty quickly during the HAZOP study and will result in some downtime and some loss of time. So indications that a field verification is necessary. Again, revision blocks and dates on P&IDs are not current. And, you start talking during the HAZOP study, you start discussing what changes have occurred, and you start hearing this was changed, but it's not reflected on the P&ID, or the time frame on the revision block is not matching up with what everyone is saying. So those are obvious indications. Outdated equipment information. Sometimes flow streams don't make sense. Sometimes, and that's why it's good to have a knowledgeable team. It's good to have a knowledgeable facilitator of the process. It's good to understand what's going on because that, usually is a good indication that your P&IDs are not accurate. If someone can kind of identify, hey, this is not making sense, let's take a break, make sure that this is okay, update as necessary, and let's keep moving, because otherwise you start documenting something that's not accurate. Prior to the HAZOP, you probably should do some investigative work, not probably, definitely, to make sure that P&IDs are accurate, because this is the basis. This is what you're going to be evaluating systematically. You're going to go through these as what's out on the field. So it's very important that prior to the HAZOP, spend some time, make sure that these P&IDs are accurate. You can do that by reviewing management of change procedures, pre-startup reviews, identifying what types of changes have occurred to the system over time, and comparing against P&IDs to make sure that it's appropriately reflected in the drawings. And another source is obviously operations and maintenance. You need to interview them, because sometimes, I mean, you need to have your MOCs in place, but you also probably should double check with operations and maintenance to verify what changes have undergone for the process. And also, you want to update the control summary and any cause and effects diagrams and any supplemental diagrams as necessary. So not limited to the P&IDs, just make sure that all of your maps and diagrams that you're going to be using as supporting documentation have been reviewed in a timely manner prior to commencing your HAZOP. And also, after doing all this, I mean, it's very important just to really field verify. And if you, for some reason, you probably should do a spot check before you decide whether, you're going to establish these are updated P&IDs. Pick a section of the system, go out there, and even though you think that they're 100% updated, just go out there, do a spot check, compare what you have outlined on your P&IDs to the process. And if you see any changes, it's probably a good indication that, you probably should field verify fully your P&IDs. Do this with enough time, set a realistic timeline for it, and make sure that they're updated, because otherwise it really translates into wasted time during the HAZOP study. And if you have any, time, if there's a certain time that you have to do that, it will really be affected, and you really can't get around, making that HAZOP with inaccurate P&IDs. And I think that's what I have.
Okay, so Bill Golan. What I'd like to do is put that slide association. Okay, right before we start the QA session, I just wanted to remind everybody this is a continuing series. Our objective is basically to provide everybody with the, you need to see this, don't you? How's that? Is that better? The perils of doing this live. All right, so anyhow, October 26th is the next scheduled module. It'll be on scenario details, really how to make sure that that you uncover the information you need, and also we'll have a little workshop to kind of hammer in these points. And can you flip to the next slide? Okay, so what I'd like to do is open up for question and answer period. Also, this is an opportunity if you'd like to invoke a group discussion for all the people participating in the webinar for any facilitation challenges that you've seen and conquered, for any challenges that you've seen and want some guidance from either Judith or myself and Conquer, especially as it pertains to preparation and P&ID type issues. So we'll just go ahead and open it up. And Nicole, any questions on the chat first? Okay. How about you guys? Actually, I'll repeat. Oh, okay. Okay. I thought you were going to ask one. Okay. Okay, so the question was, how do I get the most accurate drawings? Whom do I speak with at a plant site? What kind of, who in the organization would you see to track down and get the information? The real answer is kind of what you already provided, in that the process engineer has to be the one, the focal point of the knowledge of how the system works, and so they should be the ones who are most knowledgeable of what's the most current P&ID, are they accurate, and also when it comes down to field verification too, you need to have somebody who can really understand and translate mentally what they're seeing in the field to a two-dimensional functional perspective on the system, which is what a P&ID is. And so you can't necessarily have somebody who's a computer jock that does good CAD work. They have to do good CAD work and see what's in the field and link the two. Now, so it's either the process engineer working with a CAD person, or it's a real good person who can kind of do both. And there's no magic solutions. Sometimes it is real challenging to find the right person. You just really have to push hard to get it. Judith, did you want to answer that? Okay. I'll tell you what, I better pass the mic. Why don't we do this? Those are good points.
Some of the designs I've looked at, Steve and Judith, have involved new designs, and oftentimes the only person can find is just the process lead, and sometimes the process lead doesn't have that much field experience. So it sounds like I would probably work with that person and then someone who has been in the field, or that person needs to be coming into the session, right? Because looking at as-built drawings is different than looking at drawings that are new and the units haven't been even built yet.
That'll make it work better. Okay. I think you've hit the nail on the head. You're going to have to work with both individuals. And everybody's different. You know, sometimes you'll find people that are non-degreed that really know engineering a lot better than engineers do, people who are good field people. With respect to brand new plant designs that haven't been built yet, yeah, you've got to stick with the engineering staff to start with.
Thank you.
Okay. Why don't you pass that over to Michael?
Quick question. In regards to preparation, what are some of the more common problems or issues that you see before a HAZOP study?
Yeah, just about everything that was presented is based on problems that have been encountered before. Some of them are classic. One of the biggest things that really has been the focal point all morning is the P&ID issue that Judith closed with. And in fact, I'll let her talk a little bit more about those. But I've had cases where people have sworn that they had these things field verified, they're 100% accurate, and I get them a few days before after asking for them 5 times, and they're still not right and never been updated. And these are quintessential problems of undergoing a PHA team session. Other problems that are more modern, WebEx interface. It works great if it's tested, tried, and you're dealing with lots of computer equipment, and if somebody really knows what they're doing. If you're a facilitator and you're getting into a situation where you're at a plant site and the plant personnel are supposed to talk to the engineering contractor who are on the other side of the United States, and everybody's supposed to come together, and you're dealing with different time zone issues, and invariably, in a situation that involved a multi-month series of HAZOP studies, about 25 to 40% of the time, there'd be a 15 to 20-minute delay every morning because somebody couldn't get their act together or couldn't get the equipment together. Vendor information, that's a quintessential problem. People trust vendors to do the job right because they're experts in their skid designs, in their turbine designs, or whatever. invariably, when I can get the vendors in the room and ask them questions, they know how their system works, but they've never thought about what happens if it fails. And you start asking HAZOP study questions, and you're getting very, very limited type of information. That's a very common preparation issue whenever you're dealing with vendor packages, and you always get them at the last minute, and it's always trouble trying to get information from the vendors. Other common problems are computers. I swear computers look for ways to burn you. And I know one case where in Port Arthur, when we were doing a HAZOP study with the team, the night before the hard drive crashed. And so basically what we had to do is, the motherboard failed. And so we did is swap a hard drive out of a computer. Fortunately, we had another one that was kind of like it, so we could swap it out so we had the right software on a computer that actually functioned with the motherboard. So there's all sorts of things that can go wrong. Another reason why I like to have a computer for the facilitator and a computer for the scribe is a good fraction of the time something's going to go wrong, and I'm turning my computer over to the scribe so we can take session notes. So those are a lot of the common problems that are out there. They're common occurrence. There are things to really look out for. A lot of things that can go wrong. There's a lot of things to prepare for.
Yeah, that covers most of it. The only other thing I would add is something that's pretty trivial, and it's just scheduling. Because you have all these different entities, it's really important to take the time and do it in advance with sufficient time to make sure that everyone's scheduled, facility contractors, and any other people that you're going to have. Sometimes they're flying in from all these different places. Sometimes, people are booked well in advance, and so it's really important to schedule with enough time to make sure that you have everyone that you need with a specific expertise. Whether you're looking at vendor packages or a contractor who's designing and the operations who's going to be operating the facility once it's built. So it's really important to have the schedule nailed down and make sure that you're going to have the appropriate personnel available. And then also with regards to P&IDs, it also can very much impact the scheduling. And so not having accurate P&IDs, you have these people that have come in and have set aside the time to make sure that they're available for a certain period of time, but they may not be available thereafter. So if you come into some problems with the accuracy of P&IDs and need to put stuff on hold, then that becomes a huge scheduling dilemma, just because not everyone is available to stop that day and then continue the week after. So it's just really important to make sure you're organized and have all your information accurate and with time. Cool.
I guess I'd like to make another point. Judith, I didn't hear you bring this up. If I'm covering information again, just yell. It's about quality configuration control in P&IDs. One of the things that's really tough to do is keep track of the most current P&ID and also making sure that you're working with the best information. One facility that I work with pretty frequently, they seem to have a case where they've got many different types of P&IDs with the same kind of equipment on it. They may have one P&ID for the system that's got components A through E, then another P&ID they've got components C through G, and there's a lot of overlap. So when they update their system, they may grab a P&ID and update it for that equipment, but there may be other P&IDs with the same equipment on it that don't get updated. So it's very confusing, and I would just encourage everybody to make sure that if you're going to have P&ID level type functional information in the way that Judith described it, that you really have it on only one P&ID. And so you're forced to update that, keep it up to date, and maintain some degree of configuration control. Another thing too, a lot of companies, they have it electronically, but for quick updates they have what they call red line copies that are in a certain location at the plant site. It's fine to do that. It's very controllable, but what you need is somebody who monitors that and knows that somebody's got it, and make sure it gets back there, and there's a little discipline required. And occasionally you're going to want to take those red line copies and transform them into your CAD version and bring that up to date. Judith, did you have any other points that you want to make? I got a question for you. Is there a standard symbol source for a lot of these things. I see different symbols. You pull a lube oil skid, and they use like hydraulic level symbols for their stuff, for valves and whatnot. And you see a lot of different symbols when you go from site to site or engineering contractor to engineering contractor. Are there some good sources for these things?
I think depending on what industry you're looking at, there are some sets of guidelines. You know, like IAR for refrigeration has it. I think there's some ISA standards for more petroleum type applications. And at the end of the day, when you look at the different P&IDs from facility to facility, it seems to always kind of be a hybrid of information. It's not really directly from one source or the other. There are AutoCAD standards too, it's like PIP, ISO standards. And again, when you look at each facility's P&IDs, they tend to be a hybrid between the different standards. And so there are, for the most part, general applications and general symbology, but it all kind of merges from different standards and areas, and that's, again, it goes back to just knowing that the facility has a legend and understanding what they classify as their equipment and their valving and piping, et cetera.
All right, thank you. All right, Nicole, anything else for the webinar, folks? All right, anyhow, let me thank everybody for their attendance, and we'll look forward to seeing you on October 26th. Thank you. All right, one other thing, there was going to be a small workshop, a preparation exercise. It was going to be a little challenge to do it on the webinar anyhow, so I'm going to go ahead and let you all cheat. I'm going to go ahead and send out the answers, and so you can get a little bit from the exercise without having to struggle through it over the webinar. Thank you.